like, how break lined up with how my planning was planned out got screwed up, but we can use this as a benefit. So the next lesson, continuing on what we did the last day that we actually did work together in class, is more on completing the square. Chris, you have 3 seconds to get rid of that before I pop it like an evil teacher. No. So, what I would like for us to do is work through, like with your team or on your own, I don't really care. Now, if you want the best practice, you should really try it on your own. Which means, Satya, don't immediately start saying the answers out loud, because the people around you might not like that. So, here's our goal. Work through 83. 84's kind of like meh. Hey, 7th grade friends, can I request that when you're in the hallway, I'm still able to teach? Please and thank you. So, work through 83 on your own. If you do it algebraically and you don't need algebra tiles, that's fine. But then, what I do want you to think through 84, either draw it out or like really think it through, is how could we use the area model? And if you can't figure out what it's trying to push you towards, that's where 85 comes into play. So I want you to work 83, 84, and 85 essentially on your own, and then we'll come back together.
Are there
I don't know.
Are there answers that we can check on?
You can check with each other.
Okay,
If your answers in your group don't come out to like agree with each other, either first try to figure out your mistake, but then that's where I will like come in and help alleviate that. My goal with this is after we've essentially taken a week off, do we still remember how this skill works?
No.
So
You should
that's
bring
what
me a
we're.
notes.
So look up completing the square if you need in your book. Look back to the notes that you had from last Monday. Like, use your strategy, but I'm going to utilize the fact that we just had that awkwardly timed break in the middle of the chapter to test, do we still remember this? So essentially, this is kind of like a mini mastery. If I felt like we were good enough with completing the square at this point, and I put in front of you a mini mastery saying, show me how you do this, can you? So.
Okay, so for a second, for me, I just want to make sure it's like double the root of the b value. C.
Go back in your notes if you can't remember. Look it back up in your book if you can't remember. Use completing the square if you can't remember. Like visual completing the square, like actually making a perfect square. The area model.
Wait, what? It's double the root of b.
Page 283.
Wait, 283?
It's not New Year's yet.
Now, happy Christmas.
Not even Christmas yet.
Happy
Thanksgiving.
Yeah.
So in 83, what'd we end up getting in 83 after we complete the square?
X minus 3 squared equals 2.
X minus 3 squared equals 2.
X
What about B?
b plus 1 squared equals 0.
Okay, what about C?
K minus 2 squared equals negative 5.
Ooh, I heard a couple different.
Negative 5.
Negative 5.
Negative 5.
Minus menos 5.
Okay.
Wrong, that's with time.
Shut up.
So then we think through the completing the square, and if you got to this point in 84, we kind of have this realization of like 6 breaks in half, 2 breaks in half, 4 breaks in half. And when we make it to 85, 5 doesn't break in half. So even if I get rid of my constant and I push it over to that side, well, it doesn't nicely break in half. Right? So if we think through the actual area model for I just moved of course this is off. I was just up there goofing with my projector. If I try to do this, I make an area model that looks like this, which then I heard a few of you discussing like, well, wait, what is the area of 2.5 and 2.5? What area would we be missing here? 6.25, which you could just do 25 times 25 and then move your decimal back 2 places if you want to make your life easier. So that tells me I need the constant to be 6.25. So then if I actually write this as x plus 2.5 squared What's it going to be equal to?
Negative 4.
Ooh, wait.
No,
No,
negative
it's
8.
positive.
It's positive.
No, it would be
It's just
positive
it's
4.2.
negative 6.25.
Positive
guys.
4.25.
Yes.
No, what do you-
Equals.
I have heard
4.
5 different things.
It's positive
Equals
4.25.
It's positive. Negative
No.
2.
Now, I normally trust when Thomas speaks because he normally thinks it through. So Thomas thinks it's
Negative
positive.
It would be positive. You just take away 2 from
We
6.25.
have to make this side, the left side of my equation, this has to be this. We did. We made it work.
Fine.
So for that constant, we need to make it 6.25. This equals a positive 4.25.
Wait, how would it become negative?
Is there a negative 2? Because sizes.
So they pushed it over to get rid of any constant value here so that they could do the area model. So what we actually can do, 2 different processes. Well, a lot of different processes. If we start up here, we add 4.25 to both sides. But if we start here, which is what they represented, there is no constant area. Right? They got rid of the 2. What we had to do is add 6.25, and when we do that over here, it becomes just positive 4.25. Okay with that?
Yep.
So now, moving on, if I can ever get my screen cleared. If we look at 86 being turned into perfect, well, actually, this is a repetition of essentially same problem, right, from A there. So if we look at 87, just keep moving quickly. I would like to give you guys some time to practice to make sure that we're still comfortable with these skills. How do I deal with A, and or what generalizations? I heard Satya toying around with some like half of the square or square of the half, or I don't know exactly what you're saying. Did you figure out any like general rules that we can use to help us out here?
I think it was to find the B value. No, to find the C value, you take double the root. No.
You're saying both of those
Oh, I
things
don't
backwards.
know.
It's not double the root,
Is it the root?
Thomas.
So you take
Oh,
the
yeah.
first value and
What do you mean by first value?
so like x squared, like
So the coefficient of x squared.
yeah, you take the coefficient of that.
So remember, if we think parent function, if we're all trying to like speak the same language,
Yeah.
when we're working with quadratics, we assume this is the setup. So yeah, we take the A is what you're saying.
Yeah, you take the a, and then you multiply that by the square root of c, and then you multiply it all by 2.
That sounds really challenging.
What?
I thought something else.
Square
Wait,
root
no,
of C.
no, that's not. Yes, no.
You are way over. I can't square root 52.
You could always just get rid of
Well, yeah, I can.
That's where
Chris?
you make it a square.
You can divide B by 2. And then
Square root
that
that.
square.
Yeah.
It's
Square
square
root needed.
the half,
That's what I'm saying.
not double the root. We're squaring
Yeah.
the half of
If you
B.
divide it and multiply by 2, it'll be the same.
So in a perfect square, if perfect square, C will be B divided by 2 squared. So over here,
So
what's half of B? 14. What's 14 squared?
Something.
heck.
196.
196. My constant should be 196, but that doesn't mean, hey, this is where I screwed up all the time and all through high school.
Oh, you gotta.
We don't add 196. We add the difference. Right, so this will become, I'm doing A, even though I'm writing it down here, W plus 14. What's the
Wait, you can
difference
find W.
between 196 and 52?
Yeah.
144.
Wait, what?
W equals negative
Isn't
2.
144?
It in itself is.
It's a
I'm
perfect.
missing my square though. So then
hold on.
we could say W plus 14 equals
No.
positive or negative 12. Remember, there's 2 roots.
So this probably, yeah, definitely doesn't work, but no, maybe. Could you then take the square root of both sides?
It does make
sides,
it nicer.
and
But
make it,
remember, there's 2 roots.
no, W equals. So then you could know that W plus 14 equals 12.
Positive or
Positive
negative
or negative
12. So then W is going to be
Either 2
careful.
or 26. Negative.
Yeah, negative 14.
No.
-2.
No, 2.
It's
Or no.
positive
Oh.
12, and we
Yeah.
take away 14. Because we would need to take away 14, right?
Or
Or if it's
26.
negative 12,
Oh, negative.
negative 26. So those are
Wait,
our
what?
zeros.
Wouldn't it be positive 26?
No.
14 plus
No.
No, because if you're trying to get
Never mind.
What are you even?
So most of the time, guys, if a person who you assume to be mildly intelligent is asking a question that you know is off base, just let them finish asking it. They'll normally catch themselves.
We're good.
Okay, they will normally catch themselves in the
Mildly
question.
You shouldn't assume that he's mildly.
So hold up. B is a bit more challenging then. It becomes x plus 2.5.
Equals.
Wait,
We should know this now.
No,
6.25.
It's
4.25.
2.25.
Oh,
Because to make the constant what we want it to be, which we want it to be 6.25, we need an extra 2.25.
K squared.
K or S.
Okay, K minus,
K minus 4.
not 4,
No, it's
8, half of the B value.
K minus 8 squared. K minus 17.
Wait, so
64.
Solve C on your own right now. Do C, because it's a harder form. Just don't talk to each other. Just try C on your own.
What are you doing? The difference between 66 and 17.
What we want is perfect square form. What we want is C to be the square of half of B.
would it be 81?
So what we want is C to be 64. Satya, what's the difference between 64 and 17?
81.
So don't ask me would it be 81. You know it.
What if this is
I
Jeopardy?
gotta add 81.
What if this is Jeopardy?
I did it back.
Or we could write this K minus 8 squared equals negative 81. This is where we get into imaginaries,
Right.
which are not imaginary. They're real. They exist. Just not with the system that we're working with. Right? Because if I square root a negative, I'm going
Like
to
my
get an
friends.
imaginary value. Questions on this one? How I got that negative 81?
What's the square root of negative 8?
negative 17 up to 64.
So it's K minus 8 squared equals 81.
No, obviously 0.
Is this right?
I mean, yeah.
I'm pretty sure I made a mistake.
You did make a mistake.
That's
I just kept that beginning equation like that. and just
It would
added
be
64.
plus. No, it wouldn't. It would be positive
Would it be
81.
equals
Yeah.
81?
It would be positive 81.
Yes, you made a
Yeah, it would be
mistake
positive.
because you needed to
We're not
make
ready for
17.
I
saw that part,
right?
We're not ready for imaginaries
See,
yet.
you want to add on the other side, not on the
Yeah.
Yeah.
It's imaginary.
See, I assumed that
We
you'd
did
be
it, how
right.
you?
I trusted you.
Don't ever trust me.
Never
Right
trust.
when you think you're good at something, I'm gonna throw you a mistake and see if you catch
I
it.
was trying to like tell us something with
I
That's what I would do back in high school. That's exactly that's why I screwed up back in high school. I would get stuck with like, oh, I know this and that, and I'd plug things in the wrong place.
Wait, were you?
This is that.
Yeah.
This has 64 in it. So what you have to figure out is what happens between what we have and what we want to get us there. To turn this side, if I put negative 17, into 64, what we have to do is add 81 on both sides, but then this 64 already exists inside of here.
Could you just find
It's
the square
equal
root
to
of both?
positive 81 on the right side.
Or we could just do k minus 8 equals positive or negative 9.
Be careful with how
Holy
we
crap,
write
there's a
that.
negative.
One, we're not ready for imaginary numbers, but I wanted to throw that at you and see if that might alert you of like, wait, we haven't done that yet.
What is the square root
Jacob
of
and I were
negative
ready
8?
to drop accidentally.
I might.
Imaginary
No,
numbers.
that's just.
Ready to leave.
All right, questions on that
How that
one?
works.
Just be careful where you put your 80, like whatever the difference value is that you're trying to manipulate. We have to force this to become 64. We add 81 here, but that's consumed in there. Add 81 over here, and it just sits there.
Oh yeah, I need to finish bringing that.
Look at D real quick. Because this is another trap door like what we just had. We end up with x minus 12.
And then you gotta do square
15.
What should the constant be?
144.
144. So to get there,
15.
we add 15.
It was a course addition.
Alright.
With our
Oh.
bad test.
Unless that's
Hopefully we are feeling comfortable at that now. If you would like to just work on practice work for the rest of the time, you have that opportunity.
You can have an org script today, but I might see you. I have some questions.
Oh, is this you too? Just didn't staple it. Yeah, let me stop this.
Did you have a stapler, Miss Pettigrew? Does that work?
I'll stop you.